Number 42 is a little bit different than the example we did in class with square roots because there are two of them. There are two square roots here and we need to get rid of both of them in order to solve this. So from our notes in class it says to isolate the more complicated radical and square both sides. It's hard to say which of these is more complicated. It really doesn't matter which one you think is more complicated. Just get one on one side and one on the other. So I'm going to subtract the square root of 2x plus 6 from both sides. So square root of 2x minus 9 equals 3 minus the square root of 2x plus 6. Now that I have one of the radicals isolated, I'm going to square both sides. But the thing I have to keep in mind, like I said in class, is caution. When you square both sides of an equation, you need to check your answer, because you could have extraneous solutions. So anytime you raise both sides to a power, always check your answer because you could have extraneous solutions. Alright, when I square the square root, I'm just left with 2x minus 9. When I square 3 minus square root of 2x plus 6, I can't distribute the squared, but keep in mind that when I'm squaring something, I'm multiplying it by itself, like this. Now on the right side, I just need to FOIL. So on the left side, I have 2x minus 9. On the right side, 3 times 3 is 9. Do the outer ones. Negative 3 root 2x plus 6. Do the inner ones. Negative 3 root 2x plus 6. And then the last ones. Negative root 2x plus 6 times negative root 2x plus 6. That's positive root 2x plus 6 squared. Now we need to do a decent amount of cleaning up on the right side. So 2x minus 9, 9 minus 6, root 2x plus 6. When we square the square root, we're just left with what's underneath. So I get plus 2x plus 6. I can combine this a little bit more. 2x minus 9 equals 9 plus 6 is 15. Minus 6 root 2x plus 6 plus 2x. So I've combined everything I can on each side. Now I still have a square root left. I still have a radical. So I want to do this again. I want to get that radical by itself, square both sides, and then go from there. So I'm going to move the 15 and the 2x over. The 2x's actually end up canceling on both sides, which is nice. So I move the 15 over and I get that negative 24, right, because I subtracted it, equals negative 6 radical 2x plus 6. I want to get the radical by itself, so I divide both sides by negative 6. 4 equals the square root of 2x plus 6. Now that I've isolated the radical, I square both sides again, which if we didn't notice earlier, means we need to check our solutions. We said it earlier, but it bears repeating again that when you square both sides, when you raise both sides to a power, you need to check your solutions. 4 squared is 16. This is just 2x plus 6. Subtract 6 and you get 2x equals 10, or x equals 5. Now I squared both sides. In fact, I did it twice, but whether I square both sides once, twice, 3 times, whatever, anytime you raise both sides to a power, you must check your answer. So let's check this solution in the original and see if we agree with it. So this was, in the original, square root of 2 times 5 minus 9 plus square root of 2 times 5 plus 6. And we want to know, does that equal 3? Well, this is the square root of 10 minus 9, square root of 1. Plus square root of 10 plus 6, square root of 16 equals 3. And I actually get 1 plus 4 equals 3, or 5 equals 3, which is false. So because that's false, that doesn't work, and since it was our only solution, this one actually has no solution. So all that work, 5 minutes of work, just to say we have no solution. But always check your answer when you raise both sides to a power.